All right, now we're really going to see the value of the shortcut. In this video, we're going to go over how to find the slope of a tangent line at a point, as well as how to find the equation of a tangent line to a curve at a point. So the directions say find the slope of each graph below at the designated x value. You could also be asked to find the instantaneous rate of change or the slope of the tangent line. All mean the same thing. So in order to find the slope of a curve at a point, in this case it's x equals 5, we need the derivative, the thing that gives us slopes at values. The derivative using the power rule is 2 times x minus 9. And if you're like, whoa, Groden, I don't know how you got that derivative, check out my earlier videos on how to find the derivative using the power rule. Of course, the derivative of minus 9x is 9. The derivative of 1 is 0. Now that you have your derivative, we now just need to plug 5 into that. That will give us the slope of f at 5. F prime of 5 is equal to 2 times 5 minus 9, which is equal to 10 minus 9, or 1. And so the slope of the graph of this at x equals 5 is 1. Remember, this shortcut still finds us the derivative, the function that gives us slopes of the original function at any x value. Sweet. All right, on to this one. Got a little bit of trig. We again need the derivative to find the slope of cosine x, 1/2 cosine x at pi over 4. dy dx is equal to 1/2 a coefficient. The derivative of cosine is a negative sine of x. Now we want to know what the derivative is at x equals pi over 4. Let me clean this up a little bit. Yeah, you know what? We don't need to clean it up. I'm going to leave it like that. We're going to plug in pi over 4. So I'll take away that equals sign. You could, well, you know, I guess you could rewrite it as minus 1/2 sine x if you need to. I'm going to show you a little notation here that means take the derivative at x equals pi over 4. Just in case you've been exposed to that in your classroom or you've seen that in your calculator, if you're doing that, that's what that means. dy dx at x equals pi over 4 is just plugging in pi over 4 into that derivative. So minus 1/2 sine of pi over 4. Oh yeah, not bad at all, right? So the sine of pi over 4, you gotta know your unit circle. Gotta have it down. Negative 1/2 is our coefficient times, that's root 2 over 2. Some people write that as 1 over root 2. Then we simplify. That's going to be equal to negative 1 times root 2 is negative root 2 all over a 2 times 2. And that is your slope. So that's a number that's roughly a little bit greater than 1/4 in value. So it'd be just slightly less than negative 1/4. That's it. That's your slope at a point. Okay, so then what we're going to do is we're going to now find the equation of a tangent line at an x value. So these are all problems we've done before, but we did it, much lengthier kinds of problems, right? When we did it with the limit definition. No more. They're so quick. Write the equation of the tangent line to this curve at x equals negative 1. So what we need, and what I like to write out first, is I like to write out my game plan, right? My template. So my template is y minus y1 equals m times x minus x1. Meaning I look at this and say this is my end goal of where I want to end up. So now we use this and we use it almost like a shopping list and say I need y1 and an x1 and I need a slope at a point. Let's go after that slope at a point first. So m, which would be my slope at negative 1. And you're always going to be told what point you need to find the derivative at. So f prime of negative 1, to do that we need the derivative. See how we're kind of leading ourselves saying take a derivative at negative 1. Okay, so then I need to take a derivative. The derivative of this is 3 times negative 2 is negative 6. X to the 3 minus 1 is x squared, power rule, plus x, the derivative of x is just 1. And the derivative of a constant, that being minus 4, is 0. So that's our derivative. Therefore, f prime of negative 1, which is the slope at negative 1 of this curve, is negative 6 times negative 1 squared plus 1. That simplifies down to negative 6 times 1, which is negative 6 plus 1, which is equal to negative 5. Oh yeah, we got our slope. So if I go to plug into my equation, I recognize I don't have y1, but I've got my slope, it's negative 5, and I have x minus a negative 1, or x plus 1. So I need to still find the y value when x is negative 1. How do I do that? Well, f of negative 1 is equal to, plug negative 1 into here, you'll get negative 2 times negative 1 cubed, plus negative 1 goes in for x minus 4, and we simplify. Negative 1 cubed is negative 1. times negative 2 is 2. Negative 1 minus 4 is negative 5. And so that's going to simplify to negative 3. And so now we get y minus a negative 3 is y plus 3 equals negative 5 times x plus 1. And we'll leave it there. If you have one of those teachers that wants you to simplify this, simplify it by writing it in slope-intercept form, then solve for y. But I'm not going to do that. The AB or BC exam doesn't require you to do that. This is a perfectly fine answer. But I think the big thing to take away from this is realizing that you shouldn't memorize the steps. Understand your end goal and use that as your grocery list, if you will. Tell yourself, I got to find the slope. Oh, so then I need a derivative at that x value. Oh, I have my x value, so we're good. Wait, I need my y value. How do I find that? Oh, I plug negative 1 into the function. The original function, not the derivative, because here I want the y value. Guide yourself through these problems. Don't memorize steps. Peace. Go calc this thing up. It's not a thing. I don't know where I got that from.